Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or you want to test out the project you hear about on the show, you'll need somewhere to deploy it, so check out our friends at Linode. With 200 gigabit private networking, scalable shared block storage, and a 40 gigabit public network, you get everything you need to run a fast, reliable, and bulletproof data platform. If you need global distribution, they've got that covered too with worldwide data centers, including new ones in Toronto and Mumbai. And for your machine learning workloads, they just announced dedicated CPU instances. Go to dataengineeringpodcast.com/Linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. This week's episode is also sponsored by Datacoral. They provide an AWS native, serverless data infrastructure that installs in your VPC. Datacoral helps data engineers build and manage the flow of data pipelines without having to manage any of their own infrastructure. Datacoral's customers report that their data engineers are able to spend 80% of their work time invested in data transformations rather than pipeline maintenance. Raghu Murthy, founder and CEO of Datacoral, built data infrastructures at Yahoo and Facebook, scaling from mere terabytes to petabytes of analytic data. He started Datacoral with the goal to make SQL the universal data programming language. Visit dataengineeringpodcast.com/Datacoral today to find out more. You listen to this show to learn and stay up to date with what's happening in databases, streaming platforms, big data, and everything else you need to know about modern data management. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as Dataversity, Corinium Global Intelligence, Alluxio, and Data Council. Upcoming events include the combined events of the Data Architecture Summit and Graph Forum, the Data Orchestration Summit, and Data Council in New York City. Go to dataengineeringpodcast.com/conferences today to learn more about these and other events and to take advantage of our partner discounts to save money when you register. Your host is Tobias Macy, and today I'm interviewing Nick Schrock about Dagster, an open source system for building modern data applications. So Nick, can you start by introducing yourself?
Yeah, thanks for having me, Tobias. My name is Nick Schrock. I'm the founder of a company called Elemental, and our current project is, as you mentioned, this open source framework for building data applications, which is kind of the word we use for describing systems like ETL pipelines, ML pipelines, and I'm sure we're going to get into that. Before Elemental and Dagster, the bulk of my career was spent at Facebook, where I worked from 2009 to 2017. And I worked on this team through most of my career that I formed called Product Infrastructure, whose job it was to produce technology to empower our product developers and the users that they serve. And that, that team ended up producing some open source artifacts of note, namely React, which I had nothing to do with, but I worked next to those folks for years, and then GraphQL, which I was one of the co-creators of.
And so from that, can you explain how you first got involved in the area of data management?
Yeah, absolutely. So I left Facebook in February of 2017, which is actually a little over 2 years ago. I took some time off, but I was thinking about what I was going to do next. And I actually, started talking to people across various industries because I was actually looking for kind of almost like a non-tech industry to work in that needed tech help. And then as I was talking, meaning like a legacy industry like healthcare or finance or those types of industries. And as I was talking to people across various companies and organizations, I would ask them what their primary technology challenges were. And this data engineering, data integration, ML, doing ML pipelines, analytics, et cetera, kept on coming up over and over again. And I would then kind of go to practitioners in the field and ask them like, hey, can you show me what your workflow looks like and what your tools work like? And, there's amazing compartments of technology in this sector. But when you look at kind of the developer experience, or what I'll call the builder experience, because it's not just software developers, analysts and data scientists also participate in this. From someone with my background in what I fondly call the full hipster stack, meaning like React, GraphQL, and the associated technologies, kind of the aesthetics and the tooling is just not of a quality that I was accustomed to. And then, you would go back and talk to these business leaders after talking to their engineers, and they would say something like, listen, our ability to transform healthcare, we think, is actually limited by our ability to do data processing. And then I remember this meeting distinctly, and I was like, wait. You're telling me that's what you think is preventing you from transforming American healthcare is the ability to do the moral equivalent of regularized computation on a CSV file. And they're like, yeah, that's probably it. And I was just like, this is crazy. And that kind of started me on the path of looking into this.
And given the fact that you didn't have a lot of background context in data management and data engineering before that, I'm curious how you managed to get up to speed and get so embroiled in the overall space of data engineering and data tooling, and how you identified where to approach the problem.
I mean, it's just pure immersion. I just started reading and consuming as much material as possible and talking to as many people as possible. So, yeah, I knew it was time to go back to work. I was actually on my honeymoon with my wife, and we were in a train, and I was reading Matei Zaharia's of the founder of Spark, his PhD thesis on the train, and she was like, "Nick, this is ridiculous. Like, put that paper down, and you're going back to work when we get home." But so I, Tobias, like your podcast and podcasts like it have been utterly invaluable. And through those podcasts, I also was able to connect with like-minded people and really get their feedback and understand what they were doing. I particularly, for example, loved your episode with Chris Berg about data ops. I thought that was super insightful. But effectively, it was just, when you start learning something, everyone in the history of the world who knows something at some point did not know that thing. So you just put one step in front of the other, start reading every single thing out there, talking to every person that you know about it, and then just start building and experimenting with stuff.
So from all of that, you ended up creating the Dagster project. I'm wondering if you can just explain a bit about what it is and some of the early steps of getting along that path and understanding how to approach the problem.
Yeah. So, a lot of this comes from my, everything is biased and through the lens of your previous experiences. So, I was definitely trying to think about what are the design principles that led to things like GraphQL that I thought were applicable in this space. And, I started to think a lot about why does programming in data management broadly, why does it feel so different? And what are the properties that make it so that seemingly like software engineering practices end up being different in this domain than a traditional like application domain? And as I was thinking about that, one of the properties of these systems that struck out to me is the relationship between the computation and the underlying data. Meaning in a traditional application, you have, let's say, a single database table. And that is manipulated in a transactional fashion, meaning there's lots of different pieces of software and entry points into the system that are mutating that table, right? Like this user updates this setting from this endpoint, and this other user updates this other setting from this endpoint, and all of that's a shared state. What is different about one of the big things that's different about this domain of computation is that typically there's a one-to-one correlation between a data asset and the computation that produced it. Meaning that if there's a data lake somewhere and there's a set of Parquet files that are being produced, or just say simplified, just a Parquet file, typically there has only been kind of one logical computation that has been producing that thing throughout time. Meaning that you have a function somewhere, let's say just in a very abstract sense, like a piece of computation, like a Spark job, and it's been producing daily partitions in Parquet files over and over and over again. And there's a one-to-one correlation between that set of partitions in the data lake and the computation that produced it. And you can actually generalize that to almost anything. Like all of these systems, whether you call them ETL pipelines or ML supervised learning processes or whatever, are typically just DAGs of functions that consume and produce data assets. And what was really interesting about focusing on the computation itself is that that is actually kind of a more essential definition of the data than the data itself in some ways. Let me give you an example. Imagine that you had a computation that said that, hey, I'm a computation and I produced a sequence of tuples that have strings and ints, right? And imagine that you could actually, in a really standardized way, instruct that computation to conditionally either generate a CSV with that schema or a JSON file with that schema. In reality, it's the computation that is the source of truth there and not the produced CSV or JSON file. So it was kind of this like, hey, why don't we start focusing on attaching metadata and a type system and a standardized API around these broad computations instead of the data itself? And that was kind of the fundamental insight that led to the project.
And in the tagline, you use the term modern data application for Dagster as opposed to some of the other terms that somebody might use or be familiar with, such as ETL framework or for building data pipelines. And I'm just wondering if you can describe your thinking in terms of what you mean when you say data application and some of the main types of use cases that Dagster is well suited for.
Totally. So let's frame this by talking about the term ETL. So, and again, I think this is part of the benefit of me coming in fresh to this about a year and a half ago and kind of assessing like, what's all this different terminology that used and why does it exist? So specifically, ETL, let's talk about that term, extract, transform, load. And its historical etymology is you have, the traditional one is like you have Oracle systems and you have a transactional database on one side and you have a data warehouse on the other side. And every night, you do a one-time transformation that extracts that data out of the transactional database, does some computation on it, and then loads it into a data warehouse. So what people call ETL today looks nothing like that. It looks absolutely nothing like that, meaning that it is typically multi-stage. It has multiple stages of materialization. It typically passes through multiple different computational engines, like the ingest might be through Kafka or a tool like Fivetran, then it might be in a data warehouse for a while, or maybe then Spark will operate on it, and then different systems. So the term ETL is no longer attached to its original definition. When people say ETL today, they effectively mean any computation done in the cloud. And the other thing, which I think, and the reason why we're kind of interested in capturing a new term called data application for these is one, I believe that ETL, data pipelines, supervised learning processes are all in effect the same system. They are graphs of compute that consume and produce data asset, right? Within every ML pipeline, there's an ETL pipeline. There's just one additional step that produces a model. And the other thing is that and this also kind of comes from the origin story, is that I really view this domain as in a similar spot to where front-end engineering was about 10 years ago. And back then, and the reason why it comes from this is that if you talk to anyone in data today, they'll say something like, I spend 10, 20% of my time actually doing my job and 80 to 90% of my time data cleaning. And when I kept on hearing this from people, it actually kind of started to give me these like flashbacks to talking to front-end engineers in say 2010 within Facebook. And they would say like, I spend 80 to 90% of my time fighting the browser and 10 to 20% of my time building my app. And, React really changed the world on that front. And one of the things it did is it no longer thought of front end as kind of a sequence of scripts that are stitched together and then you touch once and you never talk to them again. It's like, hey, these are now really complicated pieces of software. We need a framework that respects the problem and the discipline and lives up to the inherent complexity that's in those apps. I think that data is in a similar spot, whereas these are no longer just 5 scripts that are stitched together in a DAG that you have to run once a day. Those exist, but in reality, we are in a much more complicated world. The ETL, what were hitherto known as ETL pipelines, are much more intermixed with the business logic of your application, meaning often you're doing transformations that stream in data back into the app, and there's kind of a reflexive relationship between the data pipelining and the core behavior of the your front-end application. So these are just like far more complicated things now. And I think you need to think of them as applications, meaning like they're alive all the time. They have uptimes. There's complicated relationships within them. You have to think about it not just as a one-off script, but you have to respect the problem, write testing for it, really start to model these things in a more robust way that's amenable to both human inspection, human authoring, and tooling. And so, that's kind of why we're referring to those things as data applications. Because data applications are a multidisciplinary application where it's like authored by analysts and data engineers and data scientists. And I think that the siloing in that world is partially caused by the siloing of terminology, actually, but they're all collaborating on the same activity.
And I would also argue that application engineers are starting to bleed into the data engineering lifecycle as well, where previously the ETL engineer or data engineer would be responsible for pulling information from the system of record that the application uses. But as we get to more real-time needs and the requirement of incorporating data as it's being generated, the application engineer needs to be aware of what the overall systems are that are able to process that data downstream, particularly with the introduction of systems such as Kafka as the sort of centralized system of record for the entire application ecosystem, both for the end user applications and for the data applications. And so I think it makes sense to have this unified programming framework that everybody can understand and everybody can work together on, rather than having them be componentized and monolithic and fully vertically integrated.
I couldn't agree more. And the days of, this is why I mentioned it earlier. Your interview you had with Chris Berg about data ops. You're kind of in different words describing the data ops vision of like, there used to be this, if the analogy is DevOps, there used to be this siloing between developers and operations, and now developers are responsible for operations to some degree, in that there's like a programming model where they can program the ops. And I think we need to move to a similar world here, where you can have self-contained teams that are responsible for building the app and deploying it and also integrating it with your data applications internally. Because the people who wrote the apps know the most about the domain of their data. We shouldn't be living in a world where an application developer can wake up willy-nilly and change their data model and then break everyone else without being responsible for that.
So can you take a bit of time now to talk a bit about how Dagster itself is architected and some of the ways that it's evolved since you first began working on it?
Totally. So, Dagster, if you look at it, I think someone once told me, it's like, oh, this looks like fancy Luigi. So, at first blush, it definitely looks like a fairly traditional ETL framework. I think what distinguishes it and how it's architected is that we are very focused on allowing the developer to express what the data application is doing rather than just how it is executed. So if you look at something like Airflow, right, the primary abstractions there are just, they have operators, which then you create tasks, and then you build a dependency graph, right? And if you open up that UI, right, all you see is kind of a series of nodes and edges, and those nodes have like a single string that describes what it is, and then there's edges between them, and that's all the information that you have. And the goal of the system is to orchestrate and ensure that those computations complete, and that you can retry them and things of that nature. Dagster's primary focus, although we do some of that execution as we'll get involved, but the primary focus of Dagster is enabling the developer to express at a higher level of abstraction what those computations are doing. So when you write a solid, it's there's a type system that comes with Dagster. So every single solid is a function. We say that, hey, every single node in the graph is actually a function that consumes something and produces something, and you should be able to express that. You should also be able to overlay types on top of that so that you can do some data checking as things enter and exit the nodes, as well as express to tooling exactly what is going on with this thing. These things can also express how they get configured. We have strongly typed configuration tools. And then as the computations proceed, they actually inform the enclosing runtime about what's been happening, meaning that, hey, I produced this output. Hey, I actually created a materialization that outlives the scope of the computation. I just passed this data quality test, et cetera, et cetera. So our focus is much more on kind of this new, call it the application layer, right, for data management. And that is the kind of the primary focus of our programming model.
And since Dagster itself is focused more on the programming model and isn't vertically integrated, as I mentioned before, as opposed to tools such as Airflow that people might be familiar with, I'm curious how that changes the overall workflow and interaction of the end users of the system, and what your reasoning is for decoupling the programming layer from the actual execution context.
Yeah, so, the world of infrastructure is changing a lot. And, Airflow is an existing, let's just talk about Airflow specifically, right? Airflow is a very vertically integrated system, and it has a UI, it has an execution, like cluster management aspect to it, and it also has this user-facing API such as it is. And, because it's not layered as much, they haven't been able to move as quickly. Like, for example, Airflow still doesn't really have a coherent API layer such that you could build, really move quickly on the front end of that system in a decoupled way. But I think what's more interesting is that the world of infrastructure is just changing a lot. And, just to go back to the previous comment about that, like Dagster's primary concern is about what the data applications are doing rather than exactly how they're doing it. The how is of what these systems are going to be doing is going to be changing a ton over time. So I think there's going to be lots of different physical orchestration engines as new different cluster computing primitives come along. So, just for example, there's Dask, which you can use for cluster management if you just want to kind of do Python native. And then obviously people are really interested in computational workloads on Kubernetes. But I don't think Kubernetes will be the end all of all, compute infrastructure for all time. And so I just think that world is moving very, very quickly. And you want to be able to also be able to use a new software abstraction on existing legacy infrastructure, right? So this in some ways comes from my experience working with GraphQL. And one of the things that was really pleasantly surprising about open sourcing GraphQL was just how effectively it penetrated legacy enterprises. And the reason why is that GraphQL is a pure software abstraction that you can overlay on any programming language, any runtime, any storage engine, any ORM. And that meant if your front-end people with GraphQL wanted to go in and use GraphQL but overlay it on top of some legacy IBM WebSphere something or other, you could actually have someone write a GraphQL server which interacted with that thing. And that was an extraordinarily powerful operating modality for an abstraction to really have a lot of impact, not just amongst the cognoscenti building greenfield apps, but in an industry-wide scale. So we kind of approach this in the same dimension of having what we like to call a horizontal opinionated platform, meaning that, yes, these are just DAGs of functions. And by functions, I mean like a coarse-grained computation, meaning like a Spark job, a data warehouse job, or any sort of legacy process that you have in your system. You should be able to orchestrate those computations on arbitrary compute based on your needs and your requirements. But regardless of what's actually doing the compute and what's physically doing it's orchestrated, there's still a ton of commonality between all those things. And that's where kind of the what part of me of what Dagster is describing, meaning like it has types, metadata, et cetera, and we have common tools that can operate over all of that. And you can just actually see this trend of moving away and unbundling vertically integrated stacks kind of across a few domains of computing. all the way from content management systems to other systems. And I think this is kind of part of that.
Yeah, I think having these different composable layers provides a lot more longevity for each of those different layers independently, because as you said, today you might want to use Airflow as your actual execution context. Tomorrow it might evolve to Spark because your scaling needs have evolved, or maybe there's some new framework that's coming out that you want to be able to leverage, but you don't want to have to rewrite all of your computation just because you're running across a different actual execution engine.
Yeah. And if there's nothing else, the other thing that I really noted coming at this industry fresh is just how heterogeneous and fractured it was. Meaning that when you have teams building these data applications, even in the simplest case of like a kind of a coherent org, typically you're crossing 3 or 4 technology boundaries with dealing with these things. And in a legacy organization where it's complicated, or maybe they've even done acquisitions and stuff, the data infrastructure heterogeneity is absolutely mind-boggling. So having this kind of like this single opinionated layer that all it kind of does is describe what's going on and make it in a way that can integrate with legacy, both computational engines and legacy infrastructure, we think is really powerful.
And just quickly, I'm curious to what your evaluation process was to determine that Python was the right implementation target for Dagster, and what other language runtimes or frameworks you might have considered in the process.
So it wasn't actually, when it comes to languages, I'm a pragmatist. And for these type of systems where you want a wide variety of personas interacting with it successfully, but still being able to build so-called real software, and in the data domain, I don't think there's any choice but to use Python. Python has a lot of good things going for it. One, just like everyone in data is accustomed to it. It's highly expressive, so you can it's just a very, for these kind of metadata, metaprogramming type of frameworks, extremely useful to use. Python also, and I think this is the reason why it's been successful in this domain, is that as a programming language, it has just a vast dynamic range, meaning that I think you can grab anyone who say is proficient enough to do something complicated in Excel, and you can put them in a Jupyter notebook and they can do meaningful work. But you can also build Instagram on top of Python. And that's kind of Python's superpower. So that, what are the other choices in the data domain? Scala is in vogue. Scala does not have that dynamic range. You cannot plop an Excel user into a Scala program and expect them to be successful. And then, they're really, what other languages should I have chosen or should I have considered? Actually, it's one of those things where I don't think I even really considered another language, because to me the choice was so obvious.
And then going into Dagster, I'm curious, what were some of the main assumptions that you had, and have those been challenged or updated as you have put Dagster in front of more end users?
Yeah, that's a great question. And actually, it's kind of difficult to go back in time and reconstruct exactly, what my thinking and then the team's thinking has been in every step along the way. I think, most recently, I still think this is the correct architectural decision. But initially, we were very focused on the kind of the use case of, hey, I'm a team, I have an Airflow cluster. I want to, have a higher level programming model on top of Airflow such that my team is not, or people on my team are not manually constructing Airflow DAGs. They're programmatically generating those DAGs from some other API, in our case, Dagster. Because it was a pattern we saw over and over again. Typically, most Airflow shops of sufficient complexity have built their own layer on top of Airflow that, for whatever reason that's specific to their domain or their context, actually programmatically generates those Airflow DAGs. So we were really focused on the incremental adoption case. But our early users, a lot of them came to us. They're like, hey, I think it's really cool that you have this Airflow integration, and it actually kind of proves that the system is interesting and generic and that we won't be locked into anything. But for right now, I just really like your front end tools. And I just want to be able to build kind of like my greenfield app on top of this in kind of a one-stop shop sort of way. And that's actually what we've been working on for the last couple months, is coming up with a kind of Dagster native, vertically integrated instantiation of a Dagster system that has a scheduler and a lightweight execution engine, along with some DevOps tools. So you can just, essentially like write, we call it, we have a library called Dagster AWS init, and it spins up a node in AWS for you, spins up an RDS database, and you can go from hello world to scheduling a job in about 2 minutes with a beautiful, hosted web UI to monitor and productionize your apps. So, we kind of started out with this, horizontal integrate with everything approach, but don't be super opinionated, to actually, we do have like one instantiation of an opinion, which is like, you can, have this kind of like out of the box solution, but the architecture is still there to integrate it with other systems and other execution contexts. So, I think we've changed our initial target market at first. And then I would say the other thing is that related to that is that, this started out as a much more kind of vanilla ETL framework. And the insight that allowed it to eventually target the different execution engines has definitely been an evolution in order to kind of, so that thinking has definitely changed along the way. But I would have to think about other things in order to answer that question more fully.
And then for somebody who wants to extend Dagster and either integrate it with other systems that they're running, or add new capabilities to it, or implement their own scheduler logic, what are the different extension and integration points that Dagster exposes?
Sure. So we can go those one by one. So, for example, if you want to use a new, say, compute engine, like a new Spark. Let's say you're using Spark, but you really want to experiment with, say, there's a new kind of, not Spark successor, but a similar system that does distributed computation called Ray, for example. It's like, okay, I want to be able to use Ray within Dagster. Well, all you would do is you would kind of write one of these, what we call solids, that generically can kind of interact and wrap, kicking off a Ray job. And all you need to do is kind of look at the way we integrate with Spark and data warehouses today and kind of use those as patterns in order to build your own solids, and you're off to the races. So literally wrapping existing computational frameworks is relatively straightforward, and you can cargo cult that from our open source repo. Another example you had was, say, I want to be able to use my own scheduler for whatever I want. Well, the Dagster is fully built on a GraphQL API. So the system is very pluggable. So it'd actually be very straightforward to kind of implement your own scheduler logic, because all you would need to do is, based on some schedule, essentially execute a GraphQL mutation against our hosted installation or your hosted installation. You'd be able to in-queue jobs to be run. In terms of, if you wanted to execute this on a new orchestration engine, right, we also have kind of a pluggable API for that. And, all those examples are also checked into our open source repo. So right now we have integrations with Dask and with Airflow, where effectively we've written code that allows you to take a Dagster representation of a pipeline and then effectively compile that into either an Airflow DAG or a Dask DAG. And you would, if you wanted to use another execution engine in order to do that, you would just kind of mimic that process. So the system is designed for pluggability through and through.
And another component of a data environment that somebody might want to be able to integrate Dagster with is their metadata engine to be able to keep track of data provenance and being able to identify what are the transformations that are happening. And I'm curious what would be required for somebody to be able to extract all of the task metadata to integrate into that system.
Yeah, so that's a great question. The system is definitely designed with that in mind, meaning that you whenever you execute a solid, you know what the inputs and output types are. But in addition to that, those solids can also communicate that, hey, I have created this what we call materialization that will outlive the scope of the computation. So you can subscribe to those events via GraphQL subscription, or you can just consume them with our Python API. But what that allows you to do is a tool which is consuming those stream of events has an enormous amount of context about what's going on. It knows like when the thing was executed. It might know what container it's been executed in. It knows what configuration file was used, meaning like the Dagster configuration file was used to kick that off. And then it gets runtime information about the materialization. And it's a total user pluggable kind of structured metadata system. And so, definitely on our roadmap is for us to build our own metastore on top of this, but it's meant to be very pluggable, where you could just write a generic facility which consumes these events. And every time a materialization is consumed, you would be able to actually persist in a metadata store enough state to have full lineage and provenance on that produced materialization. So we don't have any out of the box. We don't have anything out of the box to support that right now, but it would actually be pretty straightforward to integrate that with an existing metastore. And we are just really excited about that direction. So if anyone wants to do that, please come talk to us because we love working with people who like to build on top of this.
And for somebody who is interested in getting started with Dagster and writing their own data flow or data application, can you talk through the overall workflow for somebody to be able to define all of the different computation points and integrate it and then deploy it to production and make sure that the execution contexts are configured properly?
Yeah. So, I'll just go through that quickly. So, so what do you start with? Well, you pip install Dagster, right? It is just a Python module. And what you would effectively do is to say, hello world. You would have a Python file and you would write what we call a pipeline, which is one of these DAGs, and then a solid, which is just effectively a function which defines a computation. So you write a function. That function is totally black box. You can invoke pandas, a data warehouse job, a PySpark job, whatever you want. And then you orchestrate. We have this kind of elegant DSL for stringing those solids together into a DAG. Once you do that, then what you can do is you can launch that and debug that with either in a unit testing environment, obviously, but also using our development tool called Dagit. So just locally on your machine without deploying anything, you can run Dagit, you can visualize the DAG, inspect it, you can configure an execution of it. We have this beautiful auto-completing config type system. You can then execute that locally and verify that things happen. This system, the fact that we've architected it to be executable in different contexts means that it's also executable in your local machine for testability and whatnot. And we have also kind of abstractions that help users isolate their environment from their business logic, because this is just critical for getting testing going. Okay, so now you have that working. The deploying it, with our new release, you can actually deploy that in a very straightforward fashion by kind of using our kind of DevOps tools that come with this. So once you have that pipeline written, you would then effectively type Dagster, AWS, and init, and then it would provision an instance, install the correct requirements if you need to have a requirements.txt locally, and then you're up and running in an AWS environment in your VPC, and then you can. We also have a Python API for defining schedules, which is just a light wrapper on cron. And so you can go from kind of like writing this to also deploying it very quickly. If you further want to customize it, then you can actually, we have this kind of new abstraction that we call an instance, or you can think of it as like an installation. And you can configure that thing to instead, basically you think of it when you init that AWS environment or init your local environment, you can say like, hey, instead of just doing a single threaded, single process executor, we instead want to execute this thing on top of Dask, for example. And so you would also configure your instance, which is just a YAML file in kind of a well-known spot, in order to, instead of using our native toy executor, use something like Dask. So it's definitely pluggable on multiple dimensions.
And then one of the things that you've commented on and that stands out about Dagster is the concept of strong contracts that it enforces between the different solids or computation nodes. And I'm wondering why you feel that those contracts specifically are necessary and some of the benefits that they provide during the full life cycle of building and maintaining a data application.
So this is what struck me about a lot of these systems is the amount of implicit contracting that was in these systems and how frequently unexpressed they were. Meaning that, again, contrasted to Airflow, right? Airflow, if you look at their documentation, they say that if you feel compelled to share data between your tasks, that you should consider merging them. And then actually someone wrote a system to try to pass data between tasks called XCOM, but that is generally not used that much. And I believe even the creators of it have kind of like been like, that was kind of a swing and a miss. And so, but the thing about that is that Airflow tasks are passing data between another implicitly, right? So if you have task A, which comes before task B, presumably the dependency exists only because A has changed the state of the world in such a way that it needs to happen before B, right? And if you want that to be testable, it has to have parameters and you have to pass data between them. So to me, this wasn't some massive realization. Like, I think everyone understands that there's data dependencies between these things. It's just a question of whether you express them or not in the system. I think it is critically important to express them for any number of reasons. Both in terms of human understandability, meaning like you can actually inspect this thing in a tool and understand what the computation is doing, to ensuring or guiding your users to write these things in a testable manner. Because if you can't pass data between tasks, there's no way you can test those tasks, right? And I just think that all these data applications are DAGs of functions that produce and consume data assets, and that they should be testable. You should be able to execute arbitrary subsets of them. And in order to do that, you need them to be parameterized. And some of the parameters need to come from outputs of the previous task, which means they need to be functions. And then also there's really interesting operational properties that come out of expressing your data dependencies. It's a fundamental layer on which you could build, say, fully incremental computation and have the system understand how it should memoize, produce data, and other aspects. And this all kind of, Max of Airflow fame, Max Boscheman, who's also been on your show, has written a couple blog posts about this, which kind of has been influential in my thinking about so-called functional data engineering. So I just think it's the right way to build these systems on any number of dimensions. And I think you can get a lot of value by expressing those data dependencies, those parameters in your computational graph.
And you mentioned testing a few times in there, and I've got a couple of questions along those lines. One, in terms of how Dagster itself facilitates the overall process of testing and some of the challenges that exist for testing data applications and how you approach it. But also, I'm curious how you approach defining the type system for Dagster to be able to encapsulate some of the complex elements that you need to be able to pass between things, such as things like database connections to be able to identify that there was some change in a record set, or an S3 connection for being able to define the fact that there were some Parquet files dumped into a particular bucket.
Okay. Well, I feel like you just asked those are two questions we could fill up an entire podcast on, but I will do my best. So you asked me how Dagster approaches testing, and this is a huge and important subject. Not that how Dagster does it, but the testing and the kind of data domain in general. Everyone acknowledges that it's really difficult and hard. And it's one of the things that I really noted when I first was learning about this. So in terms of things that make this domain different from application programming, the same developer operating within an application, a traditional application would be like writing lots of unit tests. You take that same human being, move them to writing one of these systems, and all of a sudden they're not writing tests anymore because it's a fundamentally different domain and it's harder to do testing on. So when I think about testing in this, I think about kind of three different layers. Let's go through them. So one is unit testing, the other is integration testing, and then we'll call it pipeline or production testing. And each of them in this environment has their own issues. So unit testing this stuff is hard. And a big reason why is typically these systems have dependencies on external pieces of infrastructure, which are effectively impossible to mock out or very difficult to mock out. This is one of the reasons why we built in a system where one of the things that we do in Dagster is that we flow around a context object throughout your entire computation. And the goal of that is instead of anywhere where you would just kind of grab some global resource, like a connection from a file, like a database connection with hard-coded values or a Spark context or whatever, you instead attach those things, those same exact objects to our context object. And that allows the runtime to control the creation of that context and therefore kind of with the same API, be able to control the environment that a user is operating within. So what I mean by that is instead of just saying global function get con, as in get connection, you would instead say context.resources.connection. And what that allows you to do is based on how you configure your computation in any specific instantiation, you can kind of swap in a different version of that connection so that you can test this stuff in a unit testing context without chasing the business logic. And, but the thing about the data domain is that you can't capture as much stuff in unit testing as you could in probably application development because of this external dependency stuff, but you can still do a lot in the unit testing environment. You can make sure that like a refactoring process worked, or if you renamed a function, if you testing out that your configurations are actually being parsed correctly, there's all sorts of changes that can be covered there. And I think it's a critical part of the process in a CI/CD pipeline. Okay, next, integration testing. So this is more like, hey, we can't mock out our Spark cluster because actually mocking out a Spark cluster would be an entire company. That's an entirely complicated piece of software itself. But what we do want to be able to do is easily parameterize the computation so that, hey, in the integration test environment, we actually spin up a very tiny test-only Spark cluster and ensure that we can, run it on a subsample of the data and still have something happen in a verifiable way. So that integration testing layer, that's what I'll emphasize on our built-in configuration system. So in order to make these pipelines testable, typically they become extraordinarily complex functions with tons of parameters that configure both how they're interacting with their environment and also where they're getting their data from. And so we fully embraced that, and we built this kind of configuration management layer that makes it easier to manage complex configuration. And one of the goals of that is to enable better integration testing so that in your CI/CD pipeline or locally, you can kind of have different instantiations of config that will do full or partial integration tests of your pipeline. That way you can kind of slice and dice your pipeline into whatever subset you want of, and then be able to execute it within different environments. And then the last component of testing in these data pipelines, which we also have full support for within Dagster, is a notion of pipeline or production tests. Now, this thinking in this area, I've deeply influenced by Abe Gong, the creator of Great Expectations, who kind of uses the term pipeline test in order to describe this. And what it says is that, one of the differences between this and traditional programming is that in data pipeline in your applications, you do not have control over your input. Instead, you're typically ingesting data from a data source you don't control. And, that means that if the data changes, some assumption about it changes. Like think about this. You look at some CSV file, you write some code, and you're parsing a CSV file. There are a bunch of implicit assumptions in that code that you wrote in order to load it in correctly. And then if in the next day's data dump, some assumption about that changed, and it's not part of a formal contract, your code will break. So what expectations are, or data quality tests, is the notion that, hey, instead of having these implicit contracts between your incoming data and your computation, which only end up getting expressed when things break, instead, why don't you front load that and say that, hey, in order for this computation to work, the incoming data has to conform to this data quality test, meaning I expect the third column to be named foo, and for at minimum 1% of them to be null, and the rest of them to be integers greater than 0. And because you cannot control the ingest, the only way you can test that and know that it happened was at production time. This is much more like a manufacturing process than a traditional software process, meaning that the data is the raw material, you're getting it shipped from someplace, but before it goes into the machine, you need to do tests on that raw material to ensure that it conforms to the requirements of the machine that you might just be breaking right now. So, we, through our abstractions, try to guide the developer, and with tooling built on those abstractions, help the developer kind of execute all those 3 layers of testing, which are all necessary for a well-functioning system. I believe your other question was about our type system and things that you pass between the solids, correct?
Correct.
All right. So the type system of Dagster is a good way to transition from those production tests, because when we went into this, it was because of that property that I was talking about, where you typically don't control the ingest, and this kind of the vast heterogeneity of systems that are used to process this, what can the type system in one of these things that proclaims to span programming languages and span different computational systems, what can it actually do? And we actually came to the conclusion that for now, the most simple and most flexible thing for a type to say in Dagster is when you say, hey, I have a solid, it has an input of type foo. All that type foo says at its core is you provided a function that says, hey, when the value is about to be passed into that solid, it needs to be able to pass this test. So literally the core kind of capability of a type in the Dagster system is that there's just a function that takes an in-memory value, does an arbitrary computation, and then returns true or false, plus some metadata about what happened. So it's a totally dynamic, flexible, and gradual typing system that allows the user to kind of customize their own types and do whatever they need to do in order to pass that type check. The type system is and the inputs and outputs all are about the data that is flowing through the system. The other things you mentioned, though, were database connections, S3 connections, things of that nature. Those we model on a different axis or dimension of the system that we call resources. And I was mentioning that context object that we flow through the entire system. A database connection or S3 connection is something you would attach to that context. And where the vision really goes here is that we want to have an entire ecosystem of those resources so that people are even thinking in terms of higher levels of abstraction. So let's take S3. What are typically people using S3 for? Well, maybe what you're doing is saying that, hey, in previous parts of this computation, I'm producing a file and I just need to stash it somewhere and have it saved so that later down the line, a solid can take that and then do some further processing on it. If you think about that abstraction, right? I think we call it file cache. We have a file cache abstraction that comes with Dagster. And there's like a local file system implementation of it. And there's also an S3 implementation of it, so that you can do that operation of stashing files somewhere for, in order to actually perform your business logic. But locally, you can just kind of say, hey, I'm operating in local mode, use the local version of that file stash resource. But then in production, it's operating in a cluster computing environment. You give me the S3 or GCS version of that same exact abstraction. And so the things that like S3 connections, database connections, and the things stacked on top of that, we model as resources because they're not business logic concerns, they're operational concerns. So our goal is to kind of have the type system and the data quality tests be about the data, the meaning of the data that's flowing through the system, and have the context and the resources aspect be about more environmental or operational concerns.
And on top of all your work on Dagster itself, you have created a company to be sort of the backstop for it in the form of Elemental. And I'm wondering how you're approaching the overall sustainability and governance of Dagster, and what your path to sustainability and success for the business happens to be, and how they relate to each other.
Yeah, that's a great question. And I think about this stuff a lot. The open source governance stuff is top of mind for me, actually, because about a year and a half ago, Lee and I and Dan, the GraphQL creators, kind of spun GraphQL out of Facebook and started the GraphQL Foundation, which is now run in concert with the Linux Foundation. And that's been a really interesting experience. And then there's also been kind of a lot of, for lack of a better term, hoopla around open source sustainability across many dimensions about should there be new licensing regimes, what's the relationship between the cloud vendors, what is proper governance. So my belief is that I like to have a pretty clear wall of separation between an open source ecosystem and any commercial entities stacked on top of it or associated with it. So I deliberately chose the name Elemental to be different from Dagster. And my goal in terms of how they're related is that the relationship between Dagster and Elemental, I hope, will be similar to the relationship between GitHub and Git structurally, meaning that Dagster will be an open source project that will forever and always be free. It's not going to be the type of thing where we just kind of flip feature flags and have enterprise features for it. It'll be a self-contained, governable open source project with very well-defined properties and very, very well-defined boundaries, such that in the future, we can have a neutral governance model that will work well. Simultaneously, though, we are also trying to build a sustainable business and a healthy business, and that's also our goal, and that's where Elemental comes in. And the reason why I like the GitHub Git analogy is that GitHub is a product. They chose to make a bunch of it closed source. It's hosted. There's a login. You have users that do stuff. People are happy paying for it. It leverages the success of Git, right? But it has its own product dynamics and whatnot. It's not just pure hosted Git. And then there's this cool dynamic, right, where GitHub made it easier to host Git, which actually increased the adoption of Git, made Git more the obvious winner, which then increased the popularity of GitHub. And there's kind of this reflexive relationship. This is what we want to do eventually with the product that will become elemental.cloud, or whatever we end up calling it, and Dagster. So Elemental will eventually be a product that would leverage the success of Dagster, meaning that if your team has adopted Dagster as a productivity tool, it will be natural, compelling, and in everyone's best interest to adopt Elemental as your data management tool that leverages the adoption of the abstraction. And I think that's like everyone's incentives are aligned if you do that well. And, you can kind of clearly communicate to your users that like you're not going to be hoodwinked into being, if you're just using this for a pure productivity tool, that's totally fine with us and Godspeed. And it's our job to build data management tooling that leverages that such that the enterprises that, contain or employ those developers that use Dagster feel really good about having a commercial relationship.
And in terms of the future roadmap of Dagster itself, I'm wondering what listeners should be keeping an eye out for, and what elements of that roadmap you consider necessary before you're comfortable cutting a 1.0 release.
Oh, the ever-present question of a 1.0 release. To me, just to, the future roadmap, I certainly think that you will see us, one, effectively based on dynamic user feedback, kind of prioritize integrations with specific parts of the ecosystem. So after this 060 release, I will imagine that the tools will look more compelling to people, in which case certain aspects of that tooling, they'll be like, hey, I understood that you had this Airflow integration. I'm really interested in using this other tool that I see my friend using, but I still can't move my company over off of Airflow in one whole shot. What can I use as a value add for this over Airflow? So we anticipate kind of maturing our integrations with other different technologies, but that will be based on user demand. I think the other thing is that you'll see us building kind of more and more tooling off these higher order layers of the computations, be able to say like, hey, I did this data quality test, I produced this materialization. So that means, you could say, you can name off any number of things you can do based on that, like a meta store, anomaly detection, data quality dashboards, all sorts of other stuff. But I think for the next, 1 to 2 months, it's going to be a very kind of more meat and potatoes type time where based on feedback, based on ergonomic issues, based on operational issues that come up, we will be evolving the programming model, our documentation, and kind of doing a getting back to basics type. In terms of a 1.0 release, to me, this is mostly about communicating expectations to the users in terms of like, hey, this is like an API we're going to stand behind for years and really commit to backwards compatibility in a like really, really serious way. And, we're super confident that this is like the base API layer for the future of the system. We still have a few kind of iterations to get with that. We're not going to be breaking people willy-nilly on this stuff, but I suspect that based on user feedback and how this stuff gets used organically around this process, that we will be changing some APIs and maybe even like taking the system in different directions. So to me, the whole 1.0 is mostly about external communication and about expectations for the future users. And it's more of a qualitative judgment than anything else.
Are there any other aspects of Dagster or your work at Elemental or your thoughts on the space of data applications that we didn't discuss yet that you'd like to cover before we close out the show?
I guess one thing I'll say is that I think most of these systems, and this goes back to kind of like what's the deal with this new terminology aspect, that is that they over specialize. So there's lots of people who build ML experimentation frameworks, for example, that are totally and wholly separate from their data engineering practice. And all of these things end up having to coexist within the same data app anyway. And so I think a lot of these tools are overly specialized. Like one thing I'm really excited about in terms of tooling that we'll be able to build is that it will be very straightforward to build ML experimentation framework over Dagster, because you can use an API to enqueue new jobs with different configuration parameters, right? Which is what you need to do in order to, say, do a hyperparameter search or things of that nature. And you should be able to use effectively just a lightly specialized tool over the same ecosystem to do ML experimentation rather than use an entirely different domain of computation. So we very deeply believe in this kind of multidisciplinary aspect of it. Like one other integration that we didn't really talk about is that Dagster has a first-class integration with Papermill, which I believe you've done an episode on. And what that system does, it allows you to turn a notebook into a function, a Jupyter notebook into a coarse-grained function effectively. And then we, in turn, allow that to easily wrap that within a solid. I guess what I'd like to emphasize is that the multidisciplinary aspect of this, that's a way for people to describe and package their computations that are actually encoded in different system, but express them in a similar and wrap them in a similar metadata system. In the same vein, we actually have kind of a prototype quality integration with DBT as well, where you can have a DBT project, which is authored by an analyst or a data engineer, and then wrap that as a solid And then you can execute it within the context of one of our pipelines. And that solid will communicate, hey, this DBT invocation produced these 3 tables and these 2 views, et cetera, et cetera. So yeah, I think that, we need this sort of unification layer, and that's what we're trying to do.
Well, for anybody who wants to follow along with the work that you're doing and get in touch, I'll have you add your preferred contact information to the show notes. And as a final question, I would just like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Yeah, I mean, I guess it's pretty self-serving, but it would be an issue if I was working on something and then thought the answer was totally different from that. I guess, from what I see, the gap in the ecosystem is somewhat Dagster shaped, I'll say, meaning that we just I don't think the gap is the one next good cluster manager or just the right ETL framework that's drag and drop that abstracts away the programmer or something. This is a software engineering discipline. And so I guess I'll just kind of answer the question is the biggest gap in tooling is just in the abstract tools that instead of trying to abstract away the programmer and instead try to kind of more upskill people who don't consider themselves programmers to participate in the software engineering process and to really treat these things seriously as applications and not as kind of these one-off scripts or something that you just want to drag and drop once and be done with it. This is one of the reasons why I'm such a huge fan of DBT, because I think one of the things they've been able to do is take people who don't conceptualize themselves as software engineers, analysts, and essentially through a really nice product, be able to allow those analysts to participate in a more industrial strength software engineering process. And I think that direction is super exciting. And we're trying to do that and trying to enable those type of tools with Dagster.
Well, thank you very much for taking the time today to join me and discuss the work that you've been doing with Dagster. It's a tool that I've been keeping a close eye on for a while now, and I look forward to using it more heavily in my own work. So thank you for all of your efforts on that front, and I hope you enjoy the rest of your day.
Thanks, Tobias. Thanks for having me.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.